Well, we have 30 people on, so I'm thinking we can go ahead and get started, and if somebody else jumps on, they can catch up. So one of the things I would ask is if you're not talking, please mute your computer or telephone so we don't get background noise. My name's Tim Stout. I'm the chair of the engineering committee. Thank you for joining us this afternoon for the engineering and happy hour session sponsored by Air Performance. Today we will be discussing CDC and ASHRAE recommended practices for air quality and air purification and COVID-19. We have multiple speakers that will be featured during this session, so please mute your line. There will be time at the end of the presentation for question and answer. Feel free to type your questions in the question and answer box at any time or wait until the end of the presentation. Before we get started, I'd like to introduce Dave Smith and everyone at Air Performance for their support. Or I'm sorry, I would like to thank Dave Smith and everyone at Air Performance Services for their support and sponsoring and presenting this session. We appreciate you guys and your knowledge and expertise in this area. I'm now going to hand it over to Dave, and he can tell us more about today's featured speaker. Welcome, Dave.
Thank you, Tim. It's nice to see everybody. So like you said, I'm Dave. I'm with APS Building Services. Today, we're going to have a couple people speaking. I'll introduce everybody that's in the room with me. We've got Tracy Pauls with Air Performances here. Hello. As well. We got Jackie Logan. We got Jack Labe. And then Alec Mackey is our speaker that's going to be, he's got a PowerPoint presentation that he can share a screen and run through. He's going to talk about several items, the ionizing type air purification, ultraviolet type air purification. We can answer questions about filters. We'll have a little bit of that in there, and that's and then we'll take questions and hope we can answer anything that you guys have going. And I guess with that, Tim, I don't know where you want to start. Do you want me to see if Alec can share his screen and just start there, or?
Yeah, that works.
Okay, we'll do that. Thank you again, everybody.
All right, I think we got it because I can hear myself on these other computers. Let's see, are you guys getting the presenter view or are you getting just the regular PowerPoint? Oh. Okay, we're good. Anyway, this presentation is typically about an hour, so I've cut out some slides and I'm going to kind of run through it pretty quickly here at the beginning so that I can make sure that everybody's got a good chance, to ask questions and everything. But typically this is what we would go through. We go through, a recap. We're going to start off and talk a little bit about the actual virus itself and air properties. And I'm going to kind of run through these. These are just things that we, introduce the slides and talk about what happened with the coronavirus. I think everybody's pretty aware of that. But what we're dealing with, so similar to like the, HIV is the virus that causes AIDS. People tend to know the name of the disease, but not the virus. So the virus is severe acute respiratory syndrome, coronavirus 2, SARS-CoV-2. The disease it causes is COVID-19. The virus travels on droplet nuclei. It's not airborne by itself, and it is 0.15 microns in size. So it's really, really small. And viruses really can't be killed. They're not a conscious living thing. They can be deactivated. You're going to hear people say destroyed, made ineffective, those kind of terms. But the way that ASHRAE kind of took the first approach is, to space cleaning, is whenever they reference indoor air quality, which is one of the 4 portions of indoor environmental quality. So the EPA and ASHRAE, I think everybody's probably familiar with ASHRAE. They've got 2 different definitions of IAQ, but they're similar. And so ASHRAE came out with a statement. This was back in April, and they said that transmission of the SARS-CoV-2 virus through the air is sufficiently likely. So that kind of caused people to start to think maybe we need to shut off our HVAC systems because we're circulating all of this, potentially polluted air. But then they immediately came out with another statement that said, in general, the disabling of heating, ventilation, and air conditioning systems is not a recommended measure to reduce the transmission. So what they did was they formed a task force, and I think we'll be able to share these presentations or this presentation with you guys so that you can use some of these links. They're pretty valuable. But you can also Google ASHRAE Epidemic Task Force. And so they gave a few methods for reopening schools and universities. And, the first one was getting as high a filtration efficiency as you can get. The second is to use air ionization or UV treatment. And the third one was to provide in-room circulation units. So then in August, so on the 19th, they created a new, they used that same task force to create a new plan for office building reopenings. So here's a few of the things that they outlined, and I would seriously recommend reading through that building readiness document that's referenced there at the bottom, because it's got some really good information. They do say be careful with Legionella, because there could be an uptick in Legionnaire's disease, which tends to develop in plumbing lines. And if your office has not been occupied, then, some of that could have started growing. So they recommend running, water above 120 degrees through your pipes for 30 minutes before you start bringing tenants back, if your building has not been running at all. This next image is actually about how the virus transmits through a space. So Holt Architects actually created a little simulation with someone coughing, and it was, after a very short period of time. You can Google this simulation, and it just shows you how quickly things start to get spread throughout the space. I think this might have been either 3 minutes or 30 minutes after one of those little people coughed. So we'll keep going and talking about the virus here. So this image in the middle is Stokes' law of particle settling. And we know that the virus does not float around in the air on its own. It has to attach to a hitchhiker to travel. So it could attach to a really, really small droplet nuclei or a piece of dust or something that gets, brushed up into the air as people move around and your air conditioning systems are running. So what this shows is you've got that larger orange circle is, I believe that's, 100 microns. And it tells you that something that is 100 microns in size takes 5.8 seconds to settle on the ground. Now that's really small dot over there on the left side of the blue picture is half a micron. And it takes 41 hours for that particle to settle on the ground. So it's important to note that the virus is still, about 1/5 of the size of that. And there are particles that the virus could attach to that are even smaller than half a micron. And in that case, you can see, it could be floating in the air forever. So we want to get those really small particles, what we call agglomerated, and to form larger particles, and then that will get carried through our HVAC system. So here's the current thinking for what we can do. The 4 main abatement strategies, you've got filtration, disinfection, ventilation, and temperature and humidity. So the temperature and humidity part has not been researched as widely as filtration and disinfection. So if we're looking at retrofitting buildings, and I know that there's some questions about that, I'm going to try to start covering those with the discussion about filtration. The first thing I want to note is what makes up air. Air is about 4/5 nitrogen, 1/5 oxygen, and then there's a very, very small amount of a very, very large amount of really, really small particles. Here's kind of a comparison. So a micron is 1/1000th of, or 1/1 millionth of a meter. Visible dust is shown by that basketball over there on the left. And then the ultrafine particles, which are the BBs over on the right, those carry the worst pollutants with them. You know,
You're going up there.
oxidative gases, VOC,
Oh,
transition metals, things like that. They're going to have the biggest impact on our lungs and bodies. So one of those little BBs compared to, you know, a basketball is a kind of can tell you exactly what we're dealing with here. So here's just, you know, show us how big a micron or a micrometer really is. This is human hair. And then if you see that little red dot there, it says PM 2.5, that's the size of a bacteria. That's about 2.5 micrometers in diameter. Keep in mind, a virus is 1/20th of that size. So they're really, really small. So if we're going to talk about, you know, what's in the air by weight and volume, 97% of what's in the air is larger than 1 micron. But if we go and look at by count, 98% of what is in the air is actually smaller than a half a micron. So that tells you that there are a lot more of those little ultrafine particles floating around. So let's talk a little bit about filtration today. Everybody knows that filters are rated by their minimum efficiency reporting value, which is a MEPR rating. Their face loading and their efficiency increases as they load. But you got to keep in mind, you're going to increase the pressure drop on your fan. And that's kind of why we don't, you know, we have to look at things on a system level, but it's not always a good idea to go and throw a bunch of high MEPR rated filters into an existing unit. So MEPR ratings, this is how they come up with it. MEPR ratings range from 0.3 to 1 or to 10 microns. And then you've got their arrestance value upon first pass of an airstream. So we look here. Virus travels on a droplet nuclei that could be much smaller than 0.3 microns. So that actually is not included in a MEPR rating yet. And then you'll notice that MEPR 13 there, that still lets 50% of potentially, you know, dangerous particles pass through, but it is a good first step to start looking at increasing your filtration efficiency. Passive filters, this is kind of a review. You're not super effective at controlling surface contagions that are actually in the space. ASHRAE does recommend that the first step is looking at, you know, higher efficiency filters for your systems. There's another option actually. This is called actively polarized media. This is a filter that has a carbon plate in between it, and they apply an electrical charge to it. What it does is it charges the particles that are passing through and allows them to load up the filter 360 degrees of the weave. So here's kind of a little animation of that. So this is a regular filter right here. It's a front loading fiber for all of the weaves on it. And, you know, it's funny because people used to think that whenever their filter got dirty, they could just go into their handler and flip the filters around. But I think they finally started to realize that when you do that, you're just blowing all the dust on the other side of the filter directly back into your space. So here's what happens with a polarization and electrostatic attraction. You've got these little particles being attracted to all sides of the media. So this allows you to hold, you know, 8 to 10 times more dust without increasing your pressure drop. So as these particles agglomerate, the actual particles themselves become charged, and they start to pick up, you know, other particles in the airstream. So here's kind of a chart that some manufacturers have released for their polarized media. It shows the dust loading capability. So, you know, if you got a regular filter that is loading 1,500 grams of dust at its maximum, some polarized media can load up to 4,500. So this allows you to, you know, not have to change your filters as often. without sacrificing the pressure drop on your fans. So you can also reduce your outdoor air intake, but that's typically when you're designing a new building, they would try and do that. But when they power those filters up, they're, MERV 15 plus rated. And obviously, as they load up with more particles, that efficiency increases. So the low pressure drop is, attractive for retrofits. And you've got, a 7-year life on these filters compared to 6 to 9 months. Typically, it depends on what we're looking at and what style of filter that they do, because some of them have, really deep 12-inch V-bank filters. Some of them are just going to be your standard 2-inch filter. So here's kind of a little demonstration that we did. Smoke removal. So that's a cigarette that he is lighting, and we're going to pump the smoke into the little glass box there with one of the polarized filter media inside of it.
Everybody look. Woo.
The smoke is going to fill that little box.
Oh.
This is just a little thing that we take around and show people, but usually nobody has a cigarette on them, so. So he pumps it and then he turns the power on to the filter, and then he's gonna, turn on a little fan. Smoke is really just a bunch of very, very tiny particles. That's why we can see it. It's just a very dense volume, but really small by size. So basically that fan pulled the air through, and he doesn't have a good video angle, but on the underside of that box, there's no smoke that gets through it. So now we're going to get into the next plan of attack for trying to take care of this virus, and it's disinfection, sterilization, and cleaning. So the CDC outlined these 3 processes: sterilization, which is a process that can destroy all the microbial life that it interacts with. Disinfection eliminates pathogenic microorganisms. And then cleaning is just, wiping down surfaces in your space and physically actually going through and cleaning. So we'll go into disinfection and sterilization. So there's 2 modes of disinfection. You can talk about surface disinfection, so your coils, your drain pans, and then your actual physical things that you've got in the space, furniture, computers, things like that. And then airstream disinfection, which is neutralizing the contaminants that are coming through your air handlers and getting into the space. And there's a lot of discussion as to which is more effective at eliminating pathogens, but we're going to see if we can try to kind of answer that question. So we've got 3 technologies here that people are using. UV lamps, which is going to be your airstream disinfection, and then bipolar ionization, which is more of a occupied space disinfection, and it also can have, some properties of disinfection in your airstream. We're not going to talk about photocatalytic oxidation, but that is out there. It's just tends to be, it can be harmful to, people in the space that use it. It's for really, really specific applications. So first thing we'll do is UV. So we know there's 3 types of UV light: UVA, UVB, and UVC. UVA and B actually are the ones that cause sunburn. And our atmosphere's ozone, our atmosphere's ozone is actually what allows us to filter out the UVC and prevent that from getting to us, because it's very damaging to skin and eyes. So about 50 to 100 years ago, in the last 5-10 decades, we started to realize that we could sterilize spaces using this UVC wavelength. And we see it all the time in air handlers. You got coil disinfection. That runs for, so if you see there, you've got these ranges, which are the intensity levels of your UV. So for coil cleaning, when you have your standard UV light, right upstream of your coil, you're looking at 50 to 100 microjoules per centimeter squared, which is the intensity. But ASHRAE has recently released information that they recommend that we use at least 1,500 microjoules per centimeter squared. And I know that there are some studies that say that you're really not disinfecting and eliminating pathogens until you're at 1,800 to 4,000 microjoules per centimeter squared. So that's a really, really high intensity, and it's not being hit. You know, when you have a UV light for cleaning your coil, you're not going to be able to really get the added effect of deactivating pathogens. So UV, I've seen a few tests on SARS-1 and influenza A, and UV has been effective at deactivating those. I haven't seen anything on the new SARS-CoV-2 virus, but they do say that influenza A should be about 4 times harder to neutralize versus this SARS-CoV-2. So one can probably make an assumption that it's going to be effective against SARS-CoV-2 as well. You do have to replace your bulbs annually. Oh, I see there's a question there. I don't know. I think we'll probably just address questions at the end, and you just put them in the chat and I'll just go through the list. Should be through here pretty shortly. So, you know, Airstream disinfection with UV lights. They're easy to install. They don't provide a lot of pressure drop on a system. It's not even a measurable amount. But they do, you know, in order to get to that intensity required for pathogen disinfection, it does require about 10 to 15 times the number of bulbs that you would have to use for just coil cleaning. So you got to change those bulbs yearly. They are dangerous to, you know, whoever is working on maintenance for that system. So this was released by NIOSH, and I believe they were studying tuberculosis, and it basically tells you the safe exposure time to UVC radiation, right there. So as you can see, if we're trying to, you know, use 1,800 to 4,000 microwatts per centimeter squared, that puts us at about 1 second, you know, a little less than, or a little more than a second of exposure time that they would recommend is safe for somebody to be, you know, in the same area as that light. So we're going to go on to the next topic, which is bipolar ionization. So bipolar ionization has also been tested against a wide variety of pathogens and, you know, things like protozoas and stuff like that, bacterias. And if you look at the results above, actually, there's one manufacturer that has been tested against the SARS-CoV-2 virus so far. That's all that I'm aware of. But they rendered 99.4% of the viral particles inactivated on a stagnant surface after being exposed to the ions for 30 minutes. So that was kind of the first thing, and I believe that test was done back in June. It took a while to get it because there were not a lot of third-party labs that wanted to actually, you know, put this virus in there and start testing it because of safety reasons, but it did have, you know, successful results. We'll talk a little bit about how it works. You've got these positive and negative ions that are, you know, hopefully being dumped into the space, and they're going to cluster together and form hydroxyls, which are basically like nature's detergent. And those hydroxyls are going to surround a pathogen or a virus, and it's going to pull one of the hydrogen molecules off of those little spikes that you see on the coronavirus. And once it does that, that virus is rendered ineffective and will, you know, be destroyed, and it's not able to reproduce anymore. So that's kind of the science behind it. And there's some videos online that go into a much deeper, you know, organic chemistry level conversation on it. But I was not an organic chemistry major, so we're gonna continue moving on this. So ions, if you know, some people question, what are you putting into our space with where all of our occupants are? Ions are really just naturally occurring, and they're typically found in places that are not as impeded by humans and, you know, buildings and things like that. So if you're at the top of a mountain or, you know, a waterfall, you're seeing ion levels of 5,000 ions per cubic centimeter of air. But then once you start to get inside buildings, we're looking at less than 100. So one of the things when we're talking about bipolar ionization is ozone generation. There is a UL listing 867 that certifies electronic air cleaners from an electrical safety standpoint. So ozone can be generated and it can cause some, you know, damage to people's lungs. It's not good for immunocompromised people. So they had to start to create these standardizations. And what they do is they put a bipolar ionizer into a chamber and run it for 8 hours. And they measure the ozone at 2 inches from the device. So if you see a device that has passed UL 867, then that means that they have successfully kept less than 50 parts per billion of ozone. Some things to watch out for, though. There are manufacturers that are mounting bipolar ionizers in the duct, and UL 867 actually doesn't apply to duct-mounted equipment, so manufacturers aren't testing for it. The thing that I always say is, if you know you want to have this conversation and compare all the different options, I like to see the test data, and you know we'll sit down, go through it together, and see. So then they decided that 50 parts per billion may be a little bit too high. And they came out with a UL 2998 listing. And this does the same exact test method, but it just has a lower threshold. So we're looking at 5 parts per billion of ozone. And this is actually in that ASHRAE document about building readiness for the pandemic. ASHRAE and the CDC said on the 19th of August, if you're considering the acquisition of bipolar ionization equipment, you will want to be sure that the equipment meets UL 2998 standard certification for zero ozone emissions. I know that the Health Department of Canada has started doing some studies on ozone, and there was some talk that they may start to have issues with people that are immunocompromised at like 40 parts per billion of ozone. So that's, you know, something that we may be hearing about in the next few months. But if we're looking at bipolar ionization devices, it's really about 3 things, which is the ion output, the safety, and the maintenance. So we covered the safety, which is the ozone generation. The next thing we want to do is talk about the ion output. So not all manufacturers are equal, and you know, different manufacturers do things better than the other ones. But what we really do need to take a look at is what we're generating. So, you know, manufacturer A may be generating 140 million ions per inch of bar, whereas manufacturer B may be generating 10 million ions per inch of bar. So you're comparing 2 different things, because the effectiveness of putting 140 million ions per inch into your space is going to be much higher, because that ion density that's getting to run through all the occupied areas is going to be much greater. So, you know, some of the other things are maintenance. There are some products that you have to replace bulbs every year. Some of them require safety switches, and they don't allow you to touch the ionization device. The ion output, like I said, can be significantly different. And then test data, again. I mean, if a company A is going to make a claim for their effectiveness against SARS-CoV-2, that is them using their product and their ion generation on that virus. Company B may come in and say, well, we're also producing ions, and company A was able to, you know, spend all this money on research and successfully find out that they have been able to deactivate SARS-CoV-2 viruses. You know, ipso facto, we can do the same thing. But the truth is that when you're looking at ion output, it does make a difference. There are some products that have been tested against SARS-CoV-2. Needlepoint bipolar ionization. There is like a UV light robot out there with 3 different wavelengths. It does A, B, and C. There was a test on that that I saw a while back. nickel foam filter heated to 200 degrees C. And then there was recently just came out an acoustic air filter that vibrates particles to capture them. And that's not to say that, you know, a lot of manufacturers have tested against other viruses. So, you know, the CDC does note that common human coronaviruses, which are just surrogates, like 229E, NL63, OC43, and HKU1, it notes down there at the bottom that they should not be confused with the SARS-CoV-2. But there have been a lot of testing done on some of those surrogate viruses with different, all sorts of different manufacturers. So if we're talking about humidity, we do just kind of want to have a quick word on it. It's important to maintain your space at between, you know, 40 to 60% humidity, because below 40%, you can start to have a lot more, you know, virus generation, and then above 60%, you start to see issues with mold and protozoas and things like that. So it's good to, you know, keep that in mind as we're looking at it. Like I said, ASHRAE and the CDC are starting to do more studies on temperature and humidity. And I think we'll start to see a lot more on what the, you know, humidity levels in your space can do with this SARS-CoV-2 virus. The last thing is, how can we know that this is working? How can we know that we're delivering ions to our space? Ion counters. You know, you can buy ion counters online that you can put in your space or that you can use as a handheld, and it'll tell you, is there ions in this space? Are we getting, you know, all the ions through our airstream into the occupied space? So you can actually, there's some companies that have wall-mounted sensors that will give you the actual ion count to your building automation system. And then they might also have sensors that just tell you that there is ions in the space. So things to distinguish and things to look for. But I think that's all I've got here. So I tried to keep it quick. I had to cut down that slide or that show from like 100 slides to what we did. So I do see a list of questions, and we can address whatever you guys have. So should we go through the 11 questions that were sent in previously? That sound good? All right, let's see how well we can answer these. Are higher MERV filters a solution for all air handlers, or does it depend on the system? It absolutely depends on the system. It is a good solution. You know, it's a good first step, as we said. But if you try to put, you know, a MERV 17 filter into an air handler that was designed around MERV 8 filters, then you're going to start to run into some serious motor issues very quickly on your supply fan, and you can even, you know, have some issues with your coil if you're not getting you know, all that refrigerant evaporated. So that's something that document that I referenced at the beginning, the building readiness team, whenever they put out that document, it actually does have kind of some good information on how to start increasing the filtration levels in an existing system. So yep.
And that you may be able to get high static motors or change your pulleys to overcome that higher static pressure drop across your filter. So that's where that would have to be looked at.
Yeah, absolutely. Do you want to sit over here, Jack, and then we'll just address them together? Yeah.
I mean, that's what I always look at is, can the fan handle the higher static pressure drop? And then if not, what options are there? And you may be able to put a bigger horsepower in or change your pulleys out to be able to handle that higher static pressure drop.
Yep. Next one, what is your recommendation regarding outside air increases? I think that increasing outside air is a great idea for, you know, trying to remove viruses from your environment. However, that's another thing that you need to probably speak with equipment manufacturers, maybe engineers and contractors, because in Texas, we don't really have a lot of extra tonnage on our existing systems. So, you know, if you try to increase your outside air, you're going to increase the load on that unit. And if that unit can't handle it, then you're going to start to have some serious issues.
ASHRAE recommendation 2013 is 5 CFM per person occupied and 0.02 CFM per square foot. So you take your occupancy certificate and tells you how many people can be in your building, multiply that times 5, and then take your square footage and multiply that times 0.02. We had a building this morning. The owner told me occupancy was 900. So 900 times 5 was 45,000. Square footage was 210 times 0.02 was 4920. So the total CFM outside air requirement was 49,200. Then right now, on a day like today, they had their outside air totally closed off. So what I'm telling people is, once you get that requirement, then get a balance company to come in and do a pitot tube traverse on your outside air louvers to verify you're bringing the proper CFM in. And then, of course, that CFM would be year round. Now you have to determine if your building can handle that CFM on the warmer days, like the 100-degree days and stuff. So that's a question and a challenge y'all are gonna have.
What are your thoughts on UV lighting? I think, as we kind of talked about earlier, I think UV lighting can be effective at deactivating pathogens. Like I said, there's no duct mounted or air handler mounted UV system that has been tested against this actual virus. But I think that once that test does happen, it's going to be effective at deactivating SARS-CoV-2, just based on its effectiveness against similar viruses. But the issue is that it has to be applied properly and it has to be maintained annually, because if you're not changing your bulbs every year, you very quickly lose intensity. And once you fall under that 1,800 or 1,500 kilojoules per centimeter squared threshold, you're not doing anything against, most types of viruses. So I think it can be effective, but it definitely needs to be done with careful consideration. Can you tell us about ionic systems? What can you tell us? Well, I think we kind of went through that. If there's any specific questions on ionic systems, feel free to put it in the chat here. Is a higher standard of MERV something we should be addressing in our air filters? Again, yes, I think that higher MERV ratings are going to be effective at pulling out some of those smaller particles that the virus hitchhikes on. But like I said, or like we saw on that MERV chart, a MERV 13 filter removes 50% of 0.3 to 1 micron particles at first pass. And so you're still letting 50% of those little guys get through. So definitely.
So when you're looking at the MERV filters, the one building engineer said today, I change them every 3 months, whether it's needed or not. I recommend you find out what your pressure drop is across that filter and do a magnehelic and measure your pressure drop. So if you were to take a square, make a square on a piece of your paper, and then put a circle in that square. On brand new filters, your biggest airflow is going to be in that circle. So your 4 corners are not going to get any airflow. Once I start packing a little bit of dirt in the circle, then I'm going to start getting air distributed through the 4 corners. And now your filters, as you load up a filter and you get up to about a 0.3 pressure drop across your filter, now you're starting to do a better job filtering the air than on brand new filters. So the filters you use, find out what your design pressure drop is, take a magnehelic and read it across the filter and change out your filters when you get to that design pressure drop. So you may get 2 months out of filters, you may get 3, you may get 4. But I always recommend doing your filter changes with a magnehelic and the pressure drop that's designed for those filters. Okay.
I was just going to bring something to your attention with the UV. From a maintenance perspective, just be conscientious that these bulbs are at about 9,000 hours. So based on how you're running your equipment, I would just take your schedule, whether you're running it on the weekends or not, and take that into consideration, because you could potentially, you could be looking at, oh my goodness, based on how many units you have, every 3 to 5 years spending $10,000 to $20,000 on bulbs. Um, it just depends on if you're running 8 hours a day, 10-hour days, 10, 12-hour days. Also, your power packs, whoever you purchase it from, you need to check your warranty and find out if you have a lifetime warranty on the emitters. Well, the emitters is the bulb, but the power packs is what supplies the power to the bulb. Find out exactly what type of warranty you get under normal usage. Those were just a couple of things I've seen that we potentially can overlook if we're not paying attention when somebody's submitting a quote or a bid. Also, on the ionic systems, some of these systems, they'll apply the negative and positive charge to get the particles out of the air, but the particles are still live, which means you'll have to come in with a disinfectant and spray. So you just took everything out of the air, but now it's on your doors, it's on your tables. There are some systems that will get it out of the air and sanitize it. So just be conscientious. If you're gonna buy something that's bipolar or has anything to do with ionic systems, make sure you understand if it's gonna sanitize or disinfect, or is it only just getting it out of the air? Go ahead, Alex.
Yeah, I mean, I think, so the next question is how often should, or wait, we talked about the MERV, yeah. How often should a deep cleaning take place? Well, that is actually another thing that is outlined in that building readiness team that ASHRAE and the CDC put together. That link that I had, or you can Google ASHRAE building readiness. I can't remember the last word, but that should be able to pull up for you. And I think that there's a section in there that outlines deep cleaning in the space and things of that nature. So that's a really great resource to use. Why COVID is the next question. I mean, unfortunately, this is what we're dealing with. How will this change leasing? So, that's a really interesting question. It's going to be kind of crazy to see how things are moving forward. I know that there are, new construction buildings that are requiring certain types of, ionization, and I think that having some of these measurements in place is going to be attractive to tenants. It's interesting because if someone comes in and they have the coronavirus and they don't know it and they drink out of a cup and then somebody else grabs that cup, drinks out of it, transmits the virus, that's not really something that you can control if that happens in a split second. But these are the measures that are being tested. There was actually a test that I got information on today. It was done by the Air Force and ACA. They basically built a big metal box and they filled it with furniture. They used 3 different types of material furniture. I think it was leather, vinyl, and I want to say the last one was maybe like a polymer or something. And they used a bipolar ionizer in the space, and it effectively deactivated 99.9% of the coronavirus that they dumped in there. So, these testing methods are getting more sophisticated because now they're actually using things that you would find in an office in their chambers and stuff like that. So I think we'll start to see a lot more of that. I think you might be able to Google for the results of that test, or I can send them to you, but it's kind of an interesting read. Let's see, are global plasma systems going overboard? I am not really sure what they mean by that question, but if anybody would like to expand on it, I'd be more than happy to try and answer that. Going overboard in terms of installations or locations or the need. I mean, I think that they are doing a lot of testing on this virus, and they have, you know, achieved a lot of higher level standards in terms of ozone generation and stuff. But going overboard, I guess, you know, that can be relative to what your definition of overboard is. If anybody wants to expand on that. All right, here's Jack.
From what we're seeing from the different management companies, the tenants are asking, what are you doing to make the building safe? So when we come back into the building, so we don't have to worry about COVID-19. That's where the biggest demand is coming from. And we've got several customers that the tenants, the property managements are saying they have bankers and lawyers in there, and they're the ones asking the question. So, and then this morning, the comment was, this tenant's looking at, well, you're not going to do anything with the new technology, but the building across the street is gonna, so if you don't do anything, we're gonna move over there. So I think it's a big, almost a fear factor right now. There's a lot of requests for information, and, you know, some are doing it, and it depends. Now, like anything, just like Legionella, it came out in about 1980, and then within a year or two, ASHRAE made standard recommendations. And I think we're going to have the same thing here as we learn more about this. I think ASHRAE is going to make recommendations, and then it's going to depend on, ASHRAE is a governing body of our industry, and they make recommendations. And then a lot of times, some of those recommendations are adopted into code, and some of them are not. So the code book is always a good point of reference as to what needs to be done now. And, you know, that may, and then depending on your tenant demands is where that goes, as far as if it's overboard or not.
Yep.
I'm gonna backtrack for a second. So for everybody on the filters, I've called several manufacturers, and a rule of thumb on the MERV 13s, because that's what everybody's going to, a 0.39 is the clean pressure drop versus a 0.5 is when the filter is considered packed or full. So if any of the engineers want to try to run some type of test themselves with a magnet helix, the difference between those two is when the filter is considered full. And that's based on traffic, occupancy, where the unit is located, and then, and how much outside air is. Yes, and if you're close to LBJ or 75, believe it or not, that plays a big part with carbon. And then with the global plasma, that process actually focuses more on the airstream. UV is more on the coil. It's direct line of sight. And to some degree, your evaporator coil becomes a filter because it starts catching everything. But the global plasma, it actually focuses on the actual molecules in the air that's passing through. And then back to the fresh air scenario, please keep in mind, if you have economizers in your building, you're bringing in a ton of fresh air 4.5 months out of the year. So you're technically looking at 7.5 months where you're going to be overly concerned with, am I bringing in enough fresh air? That what Jack told you is absolutely right. But there are some other codes based on your type of building that you may have to look at, whether or not you're in a hospital, a school, a retail center. But I would definitely go with what Jack said. It really covers all of it, despite where you may be. But my main concern was everybody wants to know, what is that pressure drop on the MERV 13s, because they're hot items. Go ahead. Hold on here, bud. Go ahead.
All right. Yeah, I mean, again, Jack and Jackie are pretty much on point with everything. Is there anything different that we need to do to maintain our HVAC to address COVID-19? From a maintenance standpoint, I mean, making sure that, you know, you've got as high efficiency as possible on your filters, and that you're, you know, regularly replacing them at whatever the recommended interval is. because you don't. Yep, clean your coils annually. Yep. Drain pan. Yeah, if you go, yeah, I don't know if y'all can hear. Yeah, I don't know if y'all can hear Jack, but he said that if you want to go above and beyond having your ducts cleaned in the tenant space, you know, after the VAV box, as you do finish out. Yeah. And let's see, the last question that I've got is, what are the best type of filters to utilize at this time? Well, the filters are great, and as much as you can, as high MERV rating as your system can handle is going to be much more effective at picking up those small particles. So, you know, again, that's a question that you need to address to the manufacturers as well and say, what can we do here? What can we handle? I know some manufacturers have 2-inch filter and 4-inch filter racks as a standard. It's, you know, you can use either size. You're going to be more effective with a MERV 13 filter that's 4 inches deep versus 2 inches, because that 2-inch filter will, you know, load up pretty quickly and start to increase, you know, pressure drop across your supply fan. So those are the kind of questions to ask is, you know, what size are our filter racks and what can we do? So I think that's all of, yeah. Okay. Yeah. Yeah. Yeah, David just mentioned that, you know, MERV 13 filters are getting on back order pretty quickly. It's a hot item. So definitely something to try to be proactive on if possible. I think Jack's got something here for us.
Another thing that we were kicking down the road this morning is put a bag filter in the filter rack and put a pre-filter on your bag. And that may accomplish the same, where you can use like a MERV 11 and then a bag filter. You change your bag filter out yearly, but your pre-filter you would change out, you know, like quarterly or when you get that pressure drop. So a bag filter may accomplish more with a pre-filter also. So that's just another option to look at, possibly. Filtration improvement is part of the answer. Cleaning the coil, making sure your drain pans don't have bacteria in it, because that's just going to add to it. And that's been addressed and everything. A lot of them are saying they're doing coil cleaning on a yearly basis. So it would be that, you know, just improve your indoor air quality is the biggest thing.
So I tried to keep the presentation brief. You know, typically it's an hour presentation. There's a lot of big words in there. So I was kind of trying to rush through that. And, you know, if we want to share it, there's some really good information in there on slides that I had hidden that just weren't really relevant to exactly what the questions were asked of us. But that's the end of our questions. So if y'all have anything for me now, feel free to just put it in the chat. Wanted to keep us at an hour since it is a happy hour. Although I don't see anyone drinking, but. Oh, there we go. Christine's got a drink. The maintenance cost of UV versus bipolar ionization. So UV lights at the intensity that we discussed need to be replaced annually. Bipolar ionization, it depends on what you are looking at and what type of, or what manufacturer you're looking at. So there are manufacturers out there that actually have bulbs on them that need to be replaced every year. There are manufacturers that you have to go in, well, actually every manufacturer. So what happens to the little carbon fibers that are on the end of the ion generator is if they fill up with dust, then you know, you start to lose your effectiveness and your ion generation. So manufacturers do recommend that you just go in and wipe down those little carbon fiber brushes once a year. And this actually brings me to another point. I know that every manufacturer that does bipolar ionization, well, not everyone, but a lot of them have your bar type products that go into a central station air handler, or, you know, can be configured to fit packaged units or things like that. And then they also have these little duct mounted modules that, you know, they don't emit as much, or they don't generate as many ions, but, you know, they may be less expensive on a per unit basis. So if you look at ion generation to ion generation, the bar products typically emit significantly more. But so people are, you know, using the small little duct mounted ones and putting a bunch of those throughout their building. Those do still have to be maintained. So if you are mounting them inside the duct, you know, all throughout your building, you may need to go get in the duct once a year and wipe down the carbon fiber emitters on those, because they will lose effectiveness once they get loaded up with dust. And I know most manufacturers, if you buy, you know, a big bar, they include a little brush in there for you that you use to just wipe down the fibers. That's a really quick process.
There was a question about how will this change leasing? I would just add that if they're gonna do any demo or change any floor plans, they need to find out who the tenant is and make all that happen before they actually move in first.
Yeah. Yeah, Jackie brought up a good point that if you're going to do any demo or changing floor plans, this is applying to the question that says how will it change leasing. You need to make sure that you know who the tenant is before you start those projects. Cool. I don't really think I have anything else.
So that's all we had. Does anybody else have any questions, or is everybody good?
That was really great information. Thank you so much. I'm a very visual person, so the videos were great to see the little particles getting onto the filters and things. So
Wait, hold on one second.
Hold on.
Sorry about that. I just realized that I had my computer muted also, so that we didn't have interference. Go ahead.
can you hear us now?
Yes.
Okay. I was just saying thank you guys for the presentation and the great information, because it's really, for me, that I just, you know, listen to the engineers and our director of operations and chief. Just, you know, it's cool to see how the filters work and how how everything, all the equipment works and everything like that. So thank you guys for the information.
Awesome. Thank you guys for the opportunity to let us do this. We appreciate it.
Very timely.
Oh, wow. Yeah, we kept it in an hour.
Perfect.
All right, guys. Well, this concludes the happy hour. So, you know, if you have any questions, feel free to reach out to Air Performance, or you can reach out to myself or anyone else in the engineering committee, and we'll see if we can get answers for you. Thanks again, Air Performance, for putting this on. It was great. And we'll see you guys in December, I believe, is our next. It's either November or December is our next event. So thank you.
Thank you, everybody.